All right, here we go. Solving one-step equations. Once again, to give you the big idea here, the big goal is to be able to solve multi-step linear equations. And if I give you that same example, just to remind you what a linear equation, a multi-step linear equation looks like when we're solving for x, something like this here. So there's distributing, collecting like terms, properties of equality. It might feel like, man, we're never going to get there. We're going to get there, man. We're getting closer and closer. Okay. So today's a big deal because, well, you'll see in just a second. It's really, it's a step that, you're always, it feels like you take almost literally in like every problem you have to do what we're going to do today with these one step equations here. So we've already done 1 and 2, and now we're on 3. A little background here. Okay, guys, there's no way I can teach you what I'm going to teach you without talking about this here. This is called the multiplicative identity. And it says anything multiplied by 1 will result in that same thing. What the heck does that mean? So let's say that you were broke and you needed some money. And I came through and I was like, well, all right, dude. I'm going to hook you up, man. I'm going to give you some money, right? But I'm only giving it to you one time. So let's say that I gave you $10, but I only gave it to you one time. So 1 times 10, right? So if I gave you $10 one time, how much would you have? $10, right? And if that same situation happened again, but instead of me giving you $10, let's say that I gave you $100, but I only gave it to you one time. So 100 times 1, or 1 times 100, right? It's the same thing. You would have $100, right? So 1 times 100 is 100. And if I gave you $1 million once, if I gave you $1 million one time, you would have $1 million, right? And so my point to you is that anything times 1 is going to be that other thing, okay? And what if it were like a box? Let's say I gave you a box that had X amount of dollars, but I only gave it to you one time, right? So instead of that money, let's say it was a box, I gave it to you and it had X amount of dollars. And I asked you the question, so how much money do you have? You would say, I have X amount of dollars, because however much money is in that box, that's how much money you're going to get, right? And that's all that they're saying here in this multiplicative identity, is that anything multiplied by 1 will result in that same thing. This is very important. You'll see in just a second, okay? So that's one thing that I got to make sure that you understand. Here is the second one. This thing is huge, man. Okay, watch this. This happens all the time in math. Property of division. So this is just a property of division, but it's really important. Any number except 0 divided by itself is always 1. This is a property of division. What the heck does that mean? Well, look, man, it's really kind of straightforward. Let's say it's you and your buddy. And I don't know if you're Mexican or not. If you're not Mexican, just fake like you're Mexican for a second, okay? So let's say you go work. Let's say I went to go work at my uncle's house, and I did a bunch of yard work for him. Me and my buddy, we split the work, right? So we were working out there, and we worked, and at the end of it, my uncle paid us, but he's like, dang, fool, I forgot my checkbook. I ain't got no money. I'm sorry, but my wife made these awesome, crazy, tight, amazing burritos. I don't know if that even looks like a burrito, man. I don't know how to make a burrito. So he gives us on a plate, he gives us 2 burritos, right? Let's just draw one big plate. That's a jacked up looking plate. Okay, let's fake like that's a really, really big tray, and those are really big burritos, right? And he paid us with those burritos. So me and my buddy are chilling right there, and he gave us 2 burritos. And then we look at each other and we're like, well, what's fair? How much should I get? How much should my buddy get? Well, it's kind of obvious, isn't it? We should each get one, right? So if we take 2 burritos and we divide them for 2 people, no equal sign, right? I'm going to simplify beneath it. It's going to be 1, right? So if there's 2 burritos and we're dividing them up evenly for 2 people, it's going to be 1. Each person is going to get 1 burrito. And really that 1 is like 1 over 1. So it's like 1 burrito for 1 person, right? And 1 divided by 1 is 1, but you get the point. Okay. So what if instead if it was 1, or let's say instead if it was 2 people, let's say it was, I don't know, like 5 people, right? So 5 people are working, right? And your crazy uncle, he don't pay, he ain't got no cash. He's like, whatever, dude. I got my wife to make some burritos. We're cool. And he makes, okay, those are really jacked up looking burritos, man. I'm sorry. He makes 5 burritos, puts them on a tray. Again, guys, what's fair, right? 5 burritos divided up evenly amongst 5 people. Everybody's going to get 1 for each person, right? So again, 5 divided by 5 is 1. 2 divided by 2 is 1. You take any number, I don't care what it is. It could be even a fraction. It could be a half divided by a half. Anything divided by itself in math always will be 1. And that's what this property of division, that's huge. You're going to see how we're going to use it in a little bit. It gets used all the way through beyond calculus, man. This property of division is huge. Okay, so any number except for 0, and that's an exception. We'll talk about that later. But any number except 0 divided by itself is always going to be 1. Let's see how that's going to play out. And don't forget that other multiplicative identity, because we're going to use that as well. So check it. Here we go. Now we're ready to solve for x. So this is an equation. Okay, we have an unknown variable, right? 5 is being multiplied by x. By the way, if you don't know, when you see 2 things in math that are just next to each other chilling like that, it's implied that they're multiplying to each other. Okay, so 5 and x are multiplying to each other. And just for structural reasoning and purposes, I'm going to always ask that you just draw a vertical line through your equal sign and keep your equal sign always on that line, okay? Some teachers don't like that because they say this looks like it's not equal to, but that's not true, okay? Just know that this doesn't mean it's not equal. We're just doing this so we can keep structure. It'll help many people, especially if you struggle with all kinds of different structural issues and people get wrong answers. This will keep us together. It's going to be kind of like our backbone, okay? Now, let's think about this, okay? Now, you might even know the answer. 5 times something is equal to 20. You probably already know what the answer is, okay? But let's do some work here, okay? So check this out. I'm going to ask you this question. I ask students it feels like almost every day when I work. Okay, so 5 times x is equal to 20. What are 5 and x doing to each other? They're multiplying, right? What number do I want 5 to become? Now remember, if I could make this 5 turn into a 1, 1 times anything is that other thing, including 1 times x will be x. And my whole goal to solve for x is to get x by itself, right? So what I'm going to do here is I want 5 to turn into 1. Well, remember that property of division? We can turn any number we want into 1 by dividing it by itself. So remember we talked about 5 burritos divided evenly amongst 5 people. That's at play right here. So 5 divided by 5, that's going to be 1, right? But if we divide this side by 5, we have to also divide this side by 5, okay? And what we're doing right now is we're using the division property of equality. So this is the first time dealing with a property of equality, but it just states that if you divide one side of an equation by a number, you have to divide the other side of the equation by that same number, just so everything stays even, okay? And so in this case, what happens is 5 divided by 5, we talked about that, right? Each person gets 1 burrito, right? So this turns into 1. And 1 times anything is that other thing, right? So 1 times x is going to be x. And now we have the right to say that we have x all by itself. And 20 divided by 5, boom, that's 4. Therefore, x is equal to 4. And if you take 4 and you replace it in the original equation, you can check it. Yeah, 5 times 4, that is 20. So that works out. Okay? So we're going to keep it simple. We're not going to go too crazy. We're not going to do all these crazy fractions and all this extra things that we can do. We'll tackle that later. We're going to look, though, at this, though. This is also very important. And I'm just going to prop this up right here now. Rules for multiplying / dividing. And hopefully you know this. I'm assuming, I teach high school, right? Algebra 1 students, and they're coming into me, and a lot of them have forgot this, or they get confused with these rules and then the rules for adding positive / negative integers. So I just wanted to differentiate between those rules and these rules. These will always be in place no matter what. Doesn't matter if the number is bigger or smaller, the sign of whoever, the signs matter, but like the bigger number, all that other stuff that we were learning for adding and subtracting, these rules are going to be different, okay? Always a negative times a positive is a negative. A negative times a positive is a negative. And notice that these signs here, these were different, right? Positive, negative, negative, positive, they were different. And the result was negative, right? And if you look over here, this is very similar to this was multiplying, right? And this one over here is dividing. And these two here are very similar. Look how you have a positive divided by a negative, or a negative divided by a positive. They're both negative, aren't they? So the results here are negative when you're having different signs. Whether you're over here, you're dividing in this column, and over here, you're multiplying right here. They're both negative, right? And if we look when the signs are the same, like negative times a negative, that's always a positive. Over here, a negative divided by a negative is always a positive, right? And over here, you have a positive times a positive is a positive. Over here, a positive divided by a positive is a positive. So this is like stuff you learned when you were a little kid, right? When you didn't even know about negatives, your whole world was only positive, right? But now that you're getting more advanced, now we got to think about these other negative things that are happening. So I'm going to draw arrows. These are kind of like, you think similarly on those two. So I'm going to put this in the description. If you want to print this out, keep this with you. It will definitely help you throughout the year. And as a matter of fact, look, it's going to help us on the next problem, because check this out. This is example 2, and they want us to solve for x. Well, we're comfortable. Well, I don't know if you're comfortable yet, but we're going to draw our equal sign on our line on the equal sign. We have -2 being multiplied by x. And I ask you the question again, what number do you want -2 to become? You want -2 to become a 1, because 1 times x will be x, and then we have the right to write x by itself. So I'm going to divide it by itself. I'm going to say -2 divided by -2. Anything divided by itself is 1, and 1 times x is x, right? And if I divide this side by -2, I have to divide this side by -2. Oh, by the way, side note, right? Negative divided by a negative is also a positive, isn't it? You can go check, rewind it, and look back at that chart. But this is a positive, and we don't have to show the sign, right? Because it's the only thing, it's the first thing that's written over here. And now we look, this is a positive 8 divided by a -2, and a positive divided by a negative is a negative, and 8 divided by 2 is 4. Bam. X equals -4. And let's go check it. Let's go plug it in. So if we were to replace this x with a -4, you would have a -2 times a -4. And then go look at that chart again, right? Negative times a negative is a positive, and then 2 times 4, that's 8. And there is that positive 8. That was the original equation that we just had, right? And that's it for example 2. Here we have to solve for x again, so I'm going to draw my line on the equal sign. I want that -6 to turn into 1, so I'm going to divide it by itself. And if I divide this side by -6, I divide this side by -6, and then we get -6 divided by -6. That's 1, and 1 times x is x. Boom, there's x. Negative divided by a negative, that's a positive. 24 divided by 6 is 4. That's a positive 4. Positive 4, and you can plug it back in. -6 times 4 is -24, so that happens to work out, and we're good. Always try to check your work. Make sure it's making sense. Here we got to solve for x. So again, -7 and x are multiplying to each other. If you want to pause it here and see if you can do it, and then unpause it, see if you get it right, It's good, man. Negative 7 times x is equal to 42. I want negative 7 to turn into 1, so I'm going to divide it by itself. If I divide this side by negative 7, I got to divide this side by negative 7. Negative 7 divided by negative 7 is 1, and 1 times x is x. And a positive divided by negative is a negative. Negative 6 is the answer there. And then negative, just checking it. Okay, you don't have to do this, but I highly recommend you do it. Negative 7 times negative 6 is positive 42, and it works out, and we're all good. All right, guys, so we're going to check out one more example. Here we're asked to solve for x. This one's just a little bit different. So remember, our goal is to get x on one side of the line all by itself with nothing else there besides just x. So in this case here, x is almost by itself, but this plus 7 is in the way, right? So we want this plus 7. Before we were trying to turn the number to the left of x into 1 so we could divide by it, or, well, we just needed to turn it into 1. But this case, it's a little bit different. Instead of us thinking that we need to turn this number into 1, we could divide everything by 7, but that would be good because then we'd still have something here. So instead, what we want is to make this plus 7 turn into the number 0. And I don't know if you remember, we were talking about this, about how, remember the negative 1 and the positive 1, they cancel out. We were talking about sand, how flat sand, if you dig a hole and a bucket of sand comes out, that hole and the bucket of sand, if you were to replace the hole with the sand, it turns into nothing and the sand is flat again, right? So we want to turn this, think of this as like excess, like 7 buckets of sand that have been taken from, or that they're just above, they're taken out of the sand, right? And so because they've been taken out of the sand, what we're going to do is we're going to fill the hole and we're going to make it we're going to make it flat again. Now, how are we going to do that? We're going to use what's called the addition. Well, actually, my bad. We're going to have to call this. It could be the addition property of equality, but really we're going to add a negative. So I'm just going to call it. That's by definition what subtracting is. So I'm going to say subtraction property of equality. So we're going to make this turn into 0 by subtracting 7. Now, the property of equality says that if you subtract 7 from the left side of the line, you have to subtract 7 from the right side of the line. And now this is disappearing, right? That's nothing. That's the number 0. We're going to let this x fall right down here. And then we're going to do 9 minus 7, which is 2. I want you to notice something, though. And there's our final answer. And if you could plug it in, 2 plus 7 is 9. And that makes sense, right? Whenever you make something turn into 0, which is what we did right here, we made this turn into 0. We have to, if you're going to use a subtraction property of equality, you got to do it at both sides, first of all. But whenever we make something turn into 0, just for structural purposes, try to always draw a horizontal line all the way through underneath that, and then bring down what's left. And remember, if you don't touch something, it just falls down. Okay, so let's look at example 6 here real quick. Solve for x. We're going to do the same thing. We're going to start with our line. This time, x is almost by itself, but now we got a negative 3. So think of this as 3 buckets of sand that have been taken from the beach, and it's like there's a hole there, right, of 3. So what we're going to use is the addition property of equality. And we're going to simply add 3 to both sides of the equation. This is now gone at 0. We're going to bring the x down. X comes over here. And then we have to add, these are like terms. One's negative, one's positive. Signs are different. We're going to look at the absolute values and subtract 10 minus 3. We're going to subtract 3 from 10. That's 7. Keep the sign of the bigger number. 10 is the bigger number. The negatives win. Negative 7 is our answer. And if we plug it in here, negative 7 plus a negative 3, that is a negative 10, so it works out. Okay, so there was solving one-step equations. Next thing I'm going to do is I'll probably, again, put up some more practice problems on a video. I'll put it in the course description, along with some practice problems that you can work through. And good luck, guys. I'll see you in the next one.